Maybe it's from Wexer. I don't know.
It is good for you to try and to say, and I'll be stating why it is we go 3 meters wide. The reason we go 3 meters wide, guys, is because when we construct, and I said this was told to you in first year too. I think I might have said that when we construct in in construction in the first year, it's for us to keep the organic matter out of the foundations because we deal with single-story dwellings, right? And for the second, when we come in third year and we do multi-story dwellings, we will be constructing. Remember, we're going up high. We're not sure how high we're going up, and it's for our scaffolding and all of that to be taken up there. The last thing we want is that when we now bring concrete or mortar or bricks or anything like that into that space, is for us to have organic matter into that space. So we clear the site 3 meters wide, we ensure that all the organic matter and everything is at least 3 meters away from the structure. That makes sense? Right. So when we now look into this and we have a look at what it is that we will be placing on there. So we will go 3 meters out wide. And if I have a look at my drawing here, my drawing tells me that overall my dimensions here would now be, what are my dimensions? Can't see. When I look at this here, I notice that my dimensions are 4 meters center, 5 meters center, 5 meters center. Oh, excuse me, guys. Oh, that was. So I sit with 14 meters from center to center, but on my beam at A1 and my beam at D1, I notice there that dimension of 4 meters and of 5 meters on the other side, it sits in the center of that beam. And I need to find the dimensions of that beam, of A1 and of D1. And I see that it's 220. So that 220, I'll then have to say 14 meters plus half of 220 on one side, plus half of 220 on the other side. And that gives me 14 meters plus 220, and my overall dimension would then be 14 to 20. Can we all see that? I need for you to speak to me. Otherwise, I'm gonna be speaking on, and I will not know if you are not with me. If everybody with me on what I've just said. No
Yes,
comment.
sir.
Are you with me on how I arrived at the 14 to 20?
Yes, sir.
Okay, fine. Now I do the same for the other side. For the other side, I see that my dimension there is 7 meter 500. You see the 7 meter 500 is indicated. Can you all see my mouse? Can you all see my mouse? Can you see my mouse moving over that area on the foundation plan?
Yes, sir.
So you saw that, right? Okay. So with that, now my dimension there is 7 meter 500 all the way down to there gives me 7 meter 500. Now when I take that 7 meter 500 again, it finds itself in the center of beam 3C and 1C. And I see that the dimensions for 3C and 1C is 220. So I go and I add 220 because it's half of that beam. It's 110 plus another 110. So that will be 220, and that leaves me 7, 7, 20. And I then have to add my 2 meter, my 2 by 3 meter on either side, which gives me 6 meters. And if I add those two, it will then give me 13, 7, 20. So the clearance of site dimension would be 20.22 by 13.72. All got that? And you could see that on the drawing. You guys need to talk to me. important that you talk to me to show that you understand where that comes from.
Yes, sir, understood.
Okay, I only hear one person speak, but it's fine. So one person speaks for the rest. Okay, so that is the clearance of my site. I sometimes would throw in trees and that, like what you've done in first year and second year, in order for you to also ensure that you take that into account. You take that and remove the trees and do all of those. Right. So when we now go forward, when we move forward, and when I now look at what I should be doing, now I should be doing my excavations. And when I do my excavations, I would then go at my excavations, and I would find that I would look at my schedule on my top left on my schedule. I would look at that, and my basis be given to me as 1100 by 1100 by 600. I have 1500 by 1500 by 600, 1100 by 1100 by 600. Those are my base sizes that I've been given, right? And it also tells me for which columns that, which bases that would be. A1 and A3. Where do I find A1 and A3? That'll be A1, that'll be A3. You can see my cursor, guys? That'll be B1 and B3. C1 and C3. D1 and D3. So what I can see is that the bases at A and D are the same size, and the bases at B and C are the same size. So I can then now look at, based on the depth that I have here of 600 for each base, the base depth, and this is what you guys can see the cursor that I have on my on my. You guys can see the cursor that I have on over here. Can you see that? Where can you see the red dot? Guys, can you see the red dot?
Yes, sir.
Okay. You see that now? Now the 600 is only from there to there. That's my 600, right? But I now need to do the excavations. I've cleared my site, and I need to do the excavation. And my excavation would now be, where my excavation be from? From there to there. That's the depth of my excavation. Okay? We got that. So I will have to add that. I will have to add that. And I will have to add that. Can you all see that? You see that I've now have 600 plus 75 plus 1150. That will be my excavation depth. Okay? You all see that? The three dimensions that I've circled. What does that mean? It means that once I've added those dimensions, I will then determine whether my excavation depth would now be exceeding 2 meters. So, my apologies. Whether it be not exceeding 2 meters, or exceeding 2, not exceeding 4, or whatever the excavation depth would be. So I would then go in and I would add all of these, and I would add the 600 plus the 1150 plus the 75. And when I add those, what depth do I get? I get a depth of, you also get 1825. Guys, I don't hear anything. You get a depth of 1825. No comment. How can I work like this? Guys, do you not get a depth of 1825?
Yes, sir.
Yes.
I got 5.
You get the depth of 1825.
Yes, sir.
Awesome. Awesome stuff. Awesome stuff. Right. Now, what does that tell me? It tells me that my excavation will be in the category not exceeding 2 meters deep. All happy with that? It tells me that my excavation would be not exceeding 2 meters deep. Because the depth that I would go, you can see the three circled depths there, and that depth would then determine where I would be going to. Got that? Okay? So that's 1825. So that being said, my description would then come from my basis, excavating pickable material for holes not exceeding 2 meters deep, and set aside for backfill for cartaway elsewhere measured. But at the same dimension, I will then also have to backfill. Why do I backfill this? It is easier for me to rather deduct when I cast my concrete than to go in and to try and cut small sections out. So I measure over and come back and deduct. I say add backfill to trenches and holes with the excavated material. What are my dimensions? I've now learned that my base sizes are 1.1 by 1.1 by 1.83. Why is that? Because the standard system says that excavation is measured in meters cubed. And I have two bases, A1 and A3 of that size. I could have said times 4 to then include D1 and D3. I've just for my own sake of sanity, I keep them separated from one another. The next one for D1, B3, C1, and C3, I will have 1.5 by 1.5 by 1.83, and there is 4 of those. That will be my excavation in the back. Then look at keeping the excavation free from water, which the standard system says is measured in as an item. And the risk of collapse I now need to measure. Very important. The risk of collapse tells us, the standard system tells us, that risk of collapse is measured in meters squared. And it is measured from ground level to not exceeding 1.5 meters deep, and from ground level to exceeding 1.5 meters deep. Now, if you look at the excavation depth, what is the excavation depth? 1.825, right? So, which side does the risk of collapse fall in here? Does it fall in the not exceeding 1.5, or does it fall in the exceeding 1.5 meters deep?
Exceeding 1.5.
Which side does it fall in?
Exceeding 1.5.
Not exceeding 1.5, right?
Exceeding.
Does it fall in the 1.5? Not exceeding 1.5 range.
It's exceeding 1.5.
Exceeding 1.5. So we now indicate, we say risk of collapse to sides of trenches, to sides of holes exceeding 1.5 meters deep from ground level. And that exceeding 1.5, I will not go and look too far. The depth that we've excavated, that is my that's my risk of collapse depth. I do not stop at 1.5 like I would do for excavation. I go to the entire depth of 1.8. So, and I'll say 4.4 times 1.83. So where do you get 4.4 from? 4.4 is 1.1, which is one side, and each base has 4 sides. 1.1 times 4 gives me 4.4. And I multiply that by 1.83, and I multiply that by 2 in this instance. The reason for me multiplying by 2, I'm splitting, I'm saying A1 and A3, that's 2, and I say times 2 again for D1 and D3. And then for B1, B3, C1, C3, it will then be 1.5 times 4 gives me 6 meters times 1.83, and I have 4 of those as well. That will be the risk of collapse. Then no frills. I do not stop at 1.5. Either exceeds 1.5 or it does not exceed 1.5. Unlike where we've measured risk of collapse in the bulk excavation, where we can have some of them exceed and some not exceed, these will either exceed or they do not exceed. Okay? So now I need to measure. Someone's mic is on. I get some horrible feedback here. Then I have my concrete that I now to measure in my blinding. The concrete in the blinding, if the strength of the blinding is not given us, we can determine, we can ascertain what the strength of the blinding would be. And I'm just saying here, concrete 15 MPa, 19 millimeter stone in blinding. Importantly, it's cast against excavated faces. And I now deduct the backfill as before. Because this backfill, I would now have over measured the backfill, and I'm deducting the volume of the concrete in the blinding from the overall backfill dimension. And then extra over excavation for parting away surplus excavated material. To a site, I just gave a dimension distance there plus minus 6 kilometers away. So for my concrete, I know that my blinding base size is 75 millimeter. And if it is 75 millimeter when written in meters, it will be 0.08 thickness. So it will be 1.1 by 1.1 by 0.08 times 2, which is for A1, A3, and times 2, which will be for D1 and D3. D1 and D3. And then 1.5 by 1.5 by 0.08 times 4 would be B1, B3, C1, and C3. That is my concrete. Straightforward, guys. There's nothing difficult about it. Okay. Then look at reinforced concrete. Now remember, I'm not changing here. You guys have done in technology. You learned that any slabs, beams, columns would have to be reinforced. Correct? Why do we reinforce it? The reinforcement assists in the prevention of collapsing of the structure. So, in our base, the base would have a reinforced cage in there. A cage that would be linked to my columns, and that column would then be linked through the steel, through the reinforced steel, into my beams and into my slabs. So that is why we are saying that it is reinforced concrete. It is strengthened. The concrete is strengthened. So reinforced concrete 20 MPa 19 millimeter stone in bases partly cast against excavated faces. Now, why do I use the term partly cast against excavated faces? I use that term because not all the concrete in the base will be against the excavated face. The bottom half of the base would be cast on the blinding. So I say partly cast against excavated faces, deduct the backfilling as before, and extra over for carting away as before. So whatever the backfilling we deducted, the over measurement that we had would now become less and less. Now I know that all my base sizes are 600 millimeter deep, and so what we have here, it will be 1.1 by 1.1 by 0.6 times 2 times 2. That covers A1, A3, D1, and D3. Also have 1.5 by 1.5 by 0.6 by 4, which covers B1, B3, C1, and C3. Then I now will be doing my columns. The columns that you see that protrude from my bases will be reinforced concrete 25 MPa 90 millimeter stone in columns. Now, the standard system tells us that when we measure in our columns, that we're not concerned with the shape of the column. We are only concerned with the shape of the columns when we're dealing with the formwork, because the standard system is clear that when we deal with different shapes of formwork of columns, that we will keep the formwork measured separately. Now we'll refer to that when I do the formwork as the next dimension. So reinforced concrete, 25 MPa, 19 millimeter stone in my columns, and I now need to determine where my columns go to. And as a rule, we measure our columns to the underside of the deepest beam. Repeat that. We measure our columns to the underside of the deepest beam. What does that mean? It means that when we look at section AA, we measure from the top of the base all the way up the underside of my deepest beam. Now, you might say, but sir, how will I know? Because we have beams of different depths here. We have beams of different depths. If you look at the beam schedule tells us that the beams 1A, 1B, 3A, 3B, and 3C, they are all 220 by 300 millimeters deep. Now, when we measure a beam, guys, a beam generally goes through the column. If I have a look at that, the beam goes, you can have a look there, we have marked in yellow, is that the beam goes to the top of the slab. Right? And that dimension that I've just indicated there, the dimension of 300 deep. That 300 deep there. That 300 deep includes the slab thickness. Now, so the beam goes, the 300 that we've had in this instance be from there to there, so that would be 300, including the slab thickness. Who with me on that? I need you to answer me quickly, guys. Do not be shy, even if 5, 6 of you speak together. I need for you to understand that the slab thickness is included in the beam size. You with me?
With you.
Hello, am I talking to myself?
Yeah, with you.
It looks like I'm talking to myself.
Sir, can you please repeat that?
Okay, what must I repeat?
How the beam is included in that distance? I didn't get that part.
Okay. The beam size that is given, you can see the 300 over there.
Yes,
Talk
sir.
to me. You see the 300 there. That 300 would be from the underside of the beam to the top of the slab.
Yes.
That is the 300 there. That 300. And the 250 and the 450. It means it is measured from the underside of the beam to the top of the slab.
Okay.
Okay? So what that means, when I look at these beams here, 1A, 1B, 1C, 3A, 3B, 3C, 2A, AB, B1, C1, and D1, I'm trying to determine the length of the column. But in order for me to determine the length of the columns, it's important for me to take into account what the beam depths are. And in this instance, when I measure from the top of the base to the underside of the beam, I will now need to look at, and I see that there's a beam that is 450. Right? And I said that we measure the columns to the underside of the deepest beam. Okay, so when I look at where do we find A1, B1, C1, and D1, I notice that this is A1, B1, C1, and D1. And what is significant about A1, B1, C1, and D1, the depths of those three beams are the same. You all see that? All the same. So what does that mean? It means that the columns at A1, A3, B1, B3, C1, C3, D1, and D3. Those columns would all be of the same height. Can you see that? Can you see that? Oh, I can't get no response. Can you guys see that? What I've just said? I think I must ask the individuals to get the response. You see? You see? Can you see those? That I say that all the column heights would be the same because the 8 columns in question all meet with the 450 millimeter deep beams. See that?
Yes, cinematic.
No response.
Yes.
Yes, sir, I can see.
Okay? Mr. Ramekwa, you can see what I'm talking about. I say that we're measuring to the underside of the deepest beam. Right? So, when I look at the length of my column, it starts out from the top of the base, it goes from 1150 to ground level, and then it has to go to the underside of the beam. But as I count, and what was significant for me was the fact that A1, B1, C1, and D1 in the beams, that they all were of the same depth. All agree with that?
Yes.
All of the same depth. You guys are welcome to also type on the side if you're scared to speak. You can type to say, yes, I agree, sir. That they all are of the same depth, and that all the columns in question meet up with those 450 deep beams. All agree with it?
Yes, sir.
Sorry, I didn't hear that. I accidentally ripped my earpiece out my ear. Did you say that you agree with me, Amodiki? Say you agree with me. Okay. I'm going to go back into my okay. Comment, I suppose. Okay. So, I've now said we've now decided that that A1 that A1, B1, C1, and D1 are all the same thickness. They are the deepest of the beams, and that my columns will go to the underside of them. Right. So how do I determine what the length of those columns are? I determine what the length of those columns are. Right? Very simple. I take this dimension. You all see the circle there, right? I take that dimension. What are those dimensions? I will write on the drawing here. 1, 1, 5, 0. Right? And I have 0. Add those is 0, 5. All happy with that dimension that I've written down there. You see those dimensions? You see them?
Yes, sir. You can see.
Okay. Right. Now, is that the length of my column?
length.
Would that be the length of my, would that be the length of my column? Why not?
No. You have to deduct the slab and the beam. That's
I have to deduct
300, I think. The
I would have
300.
to deduct. No. I would have to deduct the beam. I said earlier that all 8 my columns meet up with which beams?
The 451.
451. So what does that mean? It means that I have to deduct 50. Deduct 450, and that then gives me 0. Okay, all happy with that. So that is the height of my column. Now, I now need to determine the concrete that must go into these columns. When I look at my drawing, first of all, I see that this column and that column are the same shape. Can you all see that? That one, that one, that one, that one, that one, that one. They're the same shape. Can you see that? Right? So, I now need to determine the concrete that goes into these columns. And when I look at my dimensions that say that reinforced concrete in columns, I know that my height is 3 meters 700, but I need to determine what the concrete is that will go into my columns. And when I measure, I start from A1 and A3, they are the same shape. And I look at my drawing reference, my drawing column schedule that tells me that A1 and A3 are 340 by 340 by 220. That's the size of them. But it doesn't make sense because it shows an L shape. So what do? Because it is not a standard shape, because the shape is not standard and the shape is L shape, I now need to ensure that that is my shape of my column. I now need to ensure that I break this down into a standard shape so that I can have, on this side, I have 340, and there I would have 220, and the remainder then this here would be 220, and this overall would be 340, that there would be 120. So what does that mean? That means that I will keep this separated from that. That will all be part of A1 and A3. So my dimensions that I would have would be 0.22 by 0.34 by my depth of 3.7 times 2 of them. And I would have 0.12 by 0.22 by 3.7 times 2 of them. That would take care of A1 and A3. You all with me on that and what I've done there? That's for the concrete. You with me?
So,
Yes.
can you hear me? You know those values you got now, 340, 220. Where did you get them? Sorry, I'm starting to see the drawing. Is it in that text box?
I got them here.
340 by 340 by 220. Okay, and then you assume, not assume, but you make it.
No, that's A1 and A3.
Okay, I see grid lines A1, A3.
Yeah. Got it.
I see it. Sorry.
Okay. See, all I'm doing is I'm working with what I have in the schedule. Right? So this here, that's the shape of there. For B1, B3, C1, C3, D1, D3, straightforward, I have that's a bit out of proportion, but you guys, I have a rectangle there that is 220 my dimension there is 450. That, so those columns there are all 450, 220 by 450. That is D1, D3, C1, C3, D1, D3. So for my concrete in there, it will be 0.22 by 0.45 by 2 by 3, which will take care of B1, B3, C1, C3, D1. Is that clear? Right. So moving forward, now I need to measure the formwork. And for the formwork, I'm just going to go out. This is now, I'm going to discard everything I've done here. When I move out and I go to my formwork, apologies for that. Go to formwork. And the system says when it comes to formwork, I'm just going to upload this here quickly. I'm just going to this, then upload again, and I will upload formwork. Can you all see my screen? You see my screen that I've uploaded now?
Yes, sir.
Okay. We need to look at it. It says formwork to components. It says that formwork to walls, columns. Shall I increase the size? Can you see? You see that clearly?
See clearly.
Okay, I'll just increase it like that. Wow. Good. Formwork to walls, columns, beams, isolated beams, wall beams, slabs, wood stairs. So we measured in meters squared. Okay. Then it shall go through this the components. It tells us that, and I want to go specifically to columns. Additional requirements for formwork to columns. It tells us that columns other than circular work shall be measured in meters squared. In the formwork, columns of different shapes shall be given separately. Now, you've seen on my previous drawing that I have two L-shaped columns, and the others were all rectangular. So we will measure those two separately for formwork. When we deal with concrete does not matter how it goes in there. We cast it in there. We are not concerned with the shape. All we do is we cast the concrete in there. For the formwork, however, it's important that we keep the different shapes separated from one another. Formwork to columns shall be separated into groups for columns not exceeding 3.5 meters in height above bearing level, and thereafter for column heights above bearing level in successive stages of 1.5 meters. And what that means is that when we measure the formwork, we will start out by saying, if my formwork, we will determine what the length or the height of the column is, and that will determine which category the formwork will fall in. Now, we have already ascertained that the column heights here are all, what are the column heights? 3.7. So what does that mean? It means that my formwork would be measured in the category of exceeding 3.5, not exceeding 5 meters high from bearing level. What is this bearing level we're talking about? It is where we will place the formwork on, and the formwork will be placed on the top of my base. That is my bearing level for my columns. For the rest, as we move through this, we'll find that the bearing level changes to natural ground level, but the bearing level for these columns would be from my base.
Yeah,
That will give me a height of 3 meters 700. Further goes, it says that when we measure formwork, we will then determine, and I'll go back on this information here, it will say, tells us that formwork to walls, columns, beams cast against excavated or existing structures shall be given separately. But no deductions shall be made for openings not exceeding 3 meters square. Formwork to columns, to circular, spherical, flowing components shall be given separately, with distinction being made for work exceeding not exceeding a 1 meter radius. When dealing with the formwork, the finish of the formwork, it's important that we indicate what the finish of the formwork is. And the different finishes we will also keep separated from one another. For example, sometimes we have formwork that would be left in, permanent formwork. What do we use? We would use rubbish to keep the concrete in place, and it will not cost us too much, but we would then keep it separated. Alternatively, formwork to render a prescribed finish to the concrete surface may be given as extra over rough formwork for the different components, but we will indicate what the different finishes are, as I've said. Form to render a prescribed finish to the concrete shall be given separately for the different components. Because we have rough formwork, we have smooth formwork, we have off-shutter finish, we have different types of formwork finishes. And each one of those applications would have a different cost implication. Hence are saying that the different finishes are kept separated from one another. If nothing is given, we will just say formwork. But if you decide to say smooth formwork, you need to be consistent and using smooth formwork for all the formwork in areas where concrete would be concerned. Hence, if nothing is indicated, we would then just say formwork. So, we will now look at the formwork to these columns that we've had. I'm going to just take this out again and upload my drawing once again. Once again, when I look at my drawing, and then I see that I want to start out saying formwork to sides of rectangular shaped columns, including propping up. Now, from the word propping up, the propping up refers to the support for these columns. Exceeding 3.5, not exceeding 5 meters high from bearing level. Again, as indicated that the bearing level would
very clear.
where this formwork would be supported from. The bearing level in this instance would be on the top of that base. That will be my bearing level. When I measure for my beams or my slab, the bearing level would change to there. But for my columns, the bearing level would be the top of my bases. Right. So now when looking at my bearing level, what I do, I generally, if you guys are using the uploaded section of the workings out of this work, you notice that I have the 2x220 and 2x4. And then I have 1340. That would then be the circumference. It would be the circumference of those columns. It will be the circumference. We have added all those sides together, and that will be 1.34 by 3.7 multiplied by 2. It will be B1, B3, and then times 3, B1, C1, and D1, and D3 as well. So it will be 1.34 by 3.7 times 6. You can, of course, use the dimensions individually, but using them individually, guys, will take up plenty of time. One thing where we will need to try and save is by cutting out the middleman, cutting out and trying to take a shortcut in getting to it. I'll then say ditto, but we all shape columns ditto. Now what is that? I'm using two dittos in there. The first ditto refers to form of two sides of L-shaped columns. Including propping, and then the next one would then, the last letter would then include being for exceeding 3.5, not exceeding 5 meters high from bearing level. That's what the two dittos mean. Are there any questions around that? Okay. And again, remember that the column schedule tells me that columns A1 and A3, the sizes are 340 by 340 by 220. So all I say is, I add, say, 4 times 340, because what I have here, if I take this column here again, if I take that column, take that column, there it is 340. And there it is 340. So I have 340 and 340. So what is that dimension from there to there? Same as this. The dimension from there is the same as that. So what do I say? I say 4 by 340. All happy with what I've written there. Because I said 220 plus 110, 220 plus 110. So that plus this and that plus that gives me my 4 340s. All happy with that. That my circumference, if I add all these sides, that I would get 1360.
Homework.
All happy with that? I hear no comment.
Correct.
Happy.
Right. So my dimensions, they will then be 1.36 by my height of 3.7. And there's 2 of them. All good. Are we all good? Right. As we move through, you remember that we had over here, that we had backfill over there. You all remember that? When I did the concrete, I said deduct backfill. When I did the blinding, I said deduct backfill. When I said the base, I said deduct backfill. But now when I've cast my columns, I also need to say deduct the backfill and cart away. All with me?
Yes.
With me, guys? I take it. We are shy and understand December, we tired, so all that. So when we go through that, we now also have to, whatever said part of the column is beneath the ground. So from ground level to the base, top of the base level, we would have to deduct the concrete or the backfill in place of the concrete that was cast. So I say deduct the backfilling as before and extra over or carting away as before. I will now go back and I'll use the same dimensions that I had for my columns. And as my columns, and I will just deduct the height from the top of my base to my ground level, and that is 1150. So it will be 0.34 by 0.22 by 1.15, and 2 of them, 0.22 by 0.12 by 1.15, 2 of them, and 0.22 by 0.45 by 1.15 times 2 times 3. And that will take care of the deduction of the backfilling for where the column was cast below ground. That brings us to the end of our columns. Okay. Are we also fit? You guys see fit? Is there a chance to continue now, or shall I do another one tomorrow? Tomorrow will be better.
Tomorrow is fine.
Hello? Not hearing anything.
Tomorrow is fine.
No. Shall we continue? Because I want you guys to be fresh, because the next section of beams takes quite a bit of time. Any comments, guys?
Sir, can we do the beams tomorrow, not today?
Okay, I can do that. What is the earliest that you guys would be? And I mean early. What's the earliest? 8 o'clock.
Yeah. 10 o'clock is fine.
8 o'clock.
Yeah,
Shall I put the booking for 8 o'clock?
you.
Yes, sir.
Generally, I take no comment.
Okay.
Generally, no comment means we agree with you, sir. I've come to realize that. So 8 o'clock. We'll go 8 o'clock tomorrow morning. And I will send out the invite now, and we will do the beam tomorrow. Happy with that, Cap?